but for the evaluation they have given the broad range, and the two both the approaches are answers are falling in that range only. So we'll solve this question by using both approaches. So you can feel free to adapt one of the approaches, one of the approach. Okay, so the question is as follows: the hydraulic jump takes place in a 6-meter wide rectangular channel at a point where upstream depth is 0.5 meters. So it can be denoted as y1, which means depth before the jump, or even they mentioned in the question also just before the jump. If the discharge in the channel is 30 meter cube per second and the energy loss, so energy loss is delta E and the discharge is Q, then the fraud number computed at the end of the jump. Okay, so what is the question they asked? F2. So they are asked to calculate the F2. What is F2? F2 means depth fraud number after the jump. Let's say if I draw this figure, hydraulic jump figure, let's say this is okay, this is section 2. Let's say this is a section 1. Okay, and now they have given us this as 0.5 meter and this is y2. Okay, okay, and parallelly they have given 6 meter, 0.5, yet 1 1. Okay, these are the given data. So what else they have given? Q equal to 30 meter cube per second and the G assumed to be 10 meter per second square. Okay, and yes, delta E energy loss. Suppose here if you calculate the energy will be E1, here it will be E2, and the difference between E1 and E2 is given as 1.6 meter. So I'm giving you 1 minute. Can just try calculate by using this thing. So I have shown you this equation, the three equations. So it will be useful to solve the question. So either you can take first equation or second equation. Both the equation will give the answer. Okay. Let me interact with you now. So can anybody guess the answer? How much is the answer? Hello. Okay. Anyway, we'll see the solution in the next slide. Okay, let me go to the screen share this mode. Okay. So as so we have taken this first relation, which is like a depth y2 by y1. So we will there are two approaches I mentioned. This is approach one. This is approach one by using y2 by y1 equal to 1 by 2 square root of 1 plus 8 f1 square minus 1. Okay, this is approach one. So we'll use this particular formula and we'll solve the question. So what are the given data? One is width of the channel given as 6 meter and discharge is Q as given as a 30 meter per square meter cube per second, and depth before the jump y1 which is equal to 0.5 meter, and acceleration due to gravity is 10 meter per second square, and energy loss. So for the approach one we don't need this energy loss. This is a redundant data for us. So let's see. So as we know, what is the Froude number for rectangular channel? Froude number is F1 equal to V1 divided by root over GY1. Okay, so I have shown in the previous slide FR equal to for a rectangular channel GY, or for this is for exclusive for rectangular channel. For general case, it will be like FR equal to so Q square T by GAQ square root of. Okay, sorry. This is a for a general case. For general case. So fine, but in Most of our examples are related to rectangle, so no need to remember this q square t by g cube, but it is good if you remember this formula. But this is the most relevant formula for us, v upon root over g into y. Okay, so what we do is that first we'll calculate the forward number at upstream section. For to calculate the forward number at the downstream section is the required answer. So for to get that, we need to know what is the depth at the depth after the jump as well as the velocity after the jump. To arrive this particular quantities, we will use this relation y2 divided by y1, which is equal to 1 by 2 in 1 by 2 square root of 1 plus 8 f1 square minus 1. So we will use this particular relation and we'll calculate. In this relation, what all we know? We know y1, which is given as 0.5 meter, and f1 square, which can be calculated by using this particular formula. Okay, and so only unknown is y2. So that is straightforward answer. So what is the velocity? As we know, q equal to a into v. So for rectangular channel, a equal to b into y. Okay, so here we know the b and even know the y. So b is a 6 meter they have given, and y is 0.5 meter. So because we are calculating the section at 1, so it will be like v1. So 30 meter cube per second divided by 6 meter into 0.5 meter, which gives us the value of 10 meter per second. That is a v1. So now let's use this particular v1 to calculate the f1. So f1 equal to 10 meter per second divided by square root of, here the 10 is acceleration due to gravity, so meter per second square, and this is meter. Okay, so the 10 into 0.5, square root of 10 into 0.5, this will give us a value of 0.472. This is a Froude number before the jump. Now let's use this particular value and substitute in this equation. So y2 divided by y1 equal to 1 by 2 square root of 1 plus 8 into 4.472 whole square minus 1. So which gives us a value of 5.844. Now we know the y1 from this relation, and we can directly calculate as y2 equal to 5.844 into zero point 0.5, which gives a value of 2.992 meters. Okay, now what we know? So to calculate this f2, we know we got the value of y2 from this relation. Now our aim is to calculate this v2. So how we can calculate the v2? Again, v2 equal to, this is a discharge and this is a width will be same, even the before the jump and after them the width will be same, only the depth will change, y2. So we can substitute as q divided by b into y2. So by doing that we can get the velocity. If you clearly observe, the velocity before the jump is around 10 meter per second, but the velocity after the jump, if you see, it is 1.77 meter per second. Even similarly, the depth before the jump is given as 0.5 meter. When we compute the depth after the jump, we got around 3 nearly 3 meters. Okay, so you see the rise in the water level. Okay, now by using this v2 and y2, we can calculate the f2. So f2 equal to 1.77 divided by square root of 10 into 2.992, which is nothing but 0.316. But in the question they told to round it up to 2 decimals. So it will be like 0.136 approximately equal to 0.32. So in the exam, the range was given as 0.3 to 0.41. So our value is far lied between this range. Now let's look at the second approach. See, this is a 2 marks question. Just a substitution. Just a substitution gives us a 2 marks. If one remember this particular equation, this is easy to get 2 marks in this area. Okay, this is an alternative solution or approach to. Okay, approach to. So in this approach, what we do is that we will use the energy loss information which is given to us. So as we know, delta E equal to E1 minus E2, which is equal to Y2 minus Y1 whole cube divided by 4 into Y1 Y2. So now what we know this formula from the previous slides. Okay, so y1 y2 minus y1 whole cube equal divided by 4 y1 y2. So now substitute the values. As we know, delta E is given as 1.6 kilometer. This is the given data, and y2 and y1 we know, this is also given in the question, 0.5 meters depth before the jump, and so we substitute this equation. Okay, 1.6 into 4 into point. So now let's shuffle the terms so you can bring it here. So 1.6 into 4 into 0.5 into y2, which is equal to y2 minus 0.5 cube. Okay, so this is in the form of a minus b whole cube. So how we can expand, which is equal to a cube minus b cube minus 3a square 3ab square. If one has a confusion to expand this thing, you can written as this thing, a minus b into a minus b whole square. This a minus b is easy to, a minus b whole square is easy to remember, so we know. So a minus b can be written as a minus b a square plus b square minus 3ab. If one expand this thing, we will reach to this particular equation. So we did the similar manner here. So a cube minus b cube, okay, uh, minus 3ab square plus, sorry, 3a square b plus 3ab square, and this is a extra term we have in the other side, so we brought it back, brought to the right side, left side, and made it equal to 0. And this particular equation is difficult to solve with hand, so one can use a calculator, and by or there is a methodology to estimate the roots also. So if we estimate the roots, we have got three roots. One is to satisfy this particular equation, we got the three roots. One is 2.5 meter, another is 0.0527, another is 0.0947. But depth cannot be negative, so we can neglect these two. So final depth can be 2.5 meter. So use this particular information to calculate the V2, which is equal to 30 meter cube per second divided by 6 meter into 2.5 meter. 2.5 is the depth after the jump, and this is a width, 6 meter is a width B, and this is a Q. So as we know, Q equal to A into V. So we are doing the simple that form. We are using that formula only. So V2 equal to Q divided by B into Y2, which gives us a value of 2 meter per second. So how much we got before? We got before is 1.77 meter per second, but with help of approach 2, we have reached to the value of 2 meter per second. Okay, that there is a slight difference in the values between the approach 1 and approach 2. So but don't worry, the range, the correct value range, they have given us 0.3 to 0.41. So this alternative solution also will fall in this range only. So okay, now we know V2, and how we can calculate F2? F2 equal to V2 divided by square root of G into Y2. So as we know, Y2 equal to 2.5 meters. So by substituting this thing, we reach to the value of zero point 0.4. So in the previous approach, we got a value of 0.232. Here we got a zero point 0.4. Both the approaches are correct. Both the approaches are given full marks. So don't worry. But one point I would like to emphasize here is that just remember, by remembering three equations, these three equations, you will able to score 2 marks. Suppose if any question comes from the hydraulic jump, it is a simple marks to put it in a pocket. So just remember these two equations, your job is simple. Okay, that's it about this hydraulic jump. So there are a few other questions, but the model is same. So the values will be changed, and in the broad sense, this is the model you can expect in the gate exam. And for IES also, I have mentioned what are the questions can be asked, like for example, types of jumps, and fraud numbers for the each jump, corresponding to each jump. So if you remember these few points, that is enough for the competitive exams. Let's solve one more questions from the gate 2022. So it appeared in gate 22 set 2. The question number is 20.